Let's write quadratic functions in vertex form. Number 1. F of x equals the quantity x minus 1 times the quantity x minus 5. Step 1. Identify the x-intercepts from the factored form. We notice that this quadratic function is already in factored form, so we can identify the x-intercepts, remembering to take values out of parentheses as opposites. The first x-intercept would be a positive 1, 0, and the second x-intercept would be a positive 5, 0. How did we identify the x-intercepts? We identified the x-intercepts from factored form, taking the numeric part of the binomial factors and bringing those values out as opposites. These become the x value in the ordered pair, and x-intercepts always have an f of x or y value of 0. Step 2. Write the function in standard form and identify the y-intercept. To write the function in standard form, we just need to simplify the factored form expression. We can set up a box model with x and -1 on the rows, x and -5 on the columns. X times x equals x squared, x times -5, -5x, -1 times x, -x, -1 times -5, positive 5. Combining all the like terms available, we get the simplified expression x squared minus 6x plus 5. And this is our function now in standard form. Because our function's in standard form, we can take this numeric term and write in the y-intercept 0, positive 5. How did we write the function in standard form and identify the y-intercept? To write the function in standard form, we just needed to simplify by multiplying together these two binomials. Once we got the function in standard form, the numeric term is the f of x value of the y-intercept, with the x value being 0 because y-intercepts always have an x 0. Step 3. Write the function in vertex form and identify the vertex. To write the standard form function into vertex form, we need to complete the square of this quadratic expression. To find the missing part needed to complete the square, we take this coefficient, -6, and we divide it by 2, and then square it. -6 divided by 2 is -3, squared is positive 9. This is the value that we add after the x term and subtract at the end of the expression. F of x equals x squared minus 6x plus 9 plus 5 from the original expression minus 9 from our missing part. To write the final vertex form, we need to factor these first three terms into a perfect square binomial, and that would be x minus 3 squared, because -3 times -3 equals positive 9. -3 and -3 combined equals -6. For the numeric term, we just combine positive 5 and -9 to get -4. Now that we have our function in vertex form, we can grab the ordered pair of the vertex, remembering that values in parentheses come out as opposites. The vertex is positive 3, -4. How did we write the function in vertex form and identify the vertex? To write the function in vertex form, we took the standard form. Using the x coefficient, we were able to find the missing part and complete the square, giving us a square binomial and a numeric term. Once the function's in vertex form, then we can use the numeric term inside the square as opposite and the numeric term to create our vertex ordered pair, positive 3, -4. You are now ready to write the quadratic function in problem number 2 in vertex form.